Hello friends, this video on Arithmetic Progression Part 8 is brought to you by examfear.com. No more fear from exam. Before watching this video, please make sure that you have watched Part 1 to Part 7. Let's take one more exam. The question says, two APs have same common difference and the difference between their 100 term is 100. Find the difference between their 1000 term. So the question is something like this. A plus D, A plus 2D, A plus 3D, dash. This is AP1. And the second AP is, let's suppose, B plus D, B plus 2D, B plus 3D, dash. This is AP2. Correct? 2 AP with same common difference. So D is same actually. Now the difference between the 100 term is 100. Is, if you find a difference, A100, or for first term A100 will be nothing but A plus 99 into D. For second AP, B100 is nothing but B plus 99D. Correct? And the difference is nothing but B100 minus A100, that is B plus 99D minus A plus 99D. Correct? 99D cancel. So the difference is B minus A. And that value is nothing but 100 given. This is 100th term of first AP, 100th term of second AP. The difference is 100. Correct? And that is B minus A. Now let's find the 1000th term. A 1000 is nothing but A plus 999D, and B 1000, that is 1000 term of second series, is nothing but B plus 999D. We find the difference, that is B of 1000 minus A of 1000. What you get? B plus 999D minus A plus 999D. Correct? 9 cancel. This becomes B minus A. And B minus A is nothing but 100. So we can say that the difference of their 1000th term is also 100. Very simple. We have got 100th, A100 and B100. We found difference that came out in B minus A, and that is 100 given. Then we found A 1000s and B 1000. This is 1000th term of APA and 1000th term of APB. We found difference that came out to B minus A only, that is 100. So we can say that the difference is 100. Let's take one more example. How many 3 digits number are divisible by 7? It is a good example actually. So if you see, the first 3 digit number that is divisible by 100 is, you see the 3 digit number starts with 100, 101, 102, 103, 104, 105, 106 and so on. The first digit that is divisible by 7 is 105. We know that 100, 101, 100, 200, 300, 4 is not divisible by 7. The first 3 digit number that is divisible by 7 is 105. Correct? So the number is 105. The next 3 digit that is divisible by 7 is 112. Correct? Because the number should be of the forms 7k. 105, then 102, and the next is 119. This we know actually. The first number that is divisible by 7 is, that is 3 digit number, is 105. Second is 112, 119. And if you see, this is a AP actually, with A as 105 and D as 7. But now since it is a finite AP, we are asking only what 3 digit number. Now we have to find the last 3 digit number which is divisible by 7. Last 3 digit number is 999. If we divide by 7, what do you get? 717, 29, 74, 28, 19, 72, 40, 5. 5 is the remainder. So it's 999 minus 5, that is 994, is divisible by 7. So the last number which is divisible by 7 is 994, which is 3-digit number. So the first 3-digit number divisible by 7 is 105 and the last is 994. Little tricky here, please pay attention here. So in such question we have to find the first 3-digit number which is divisible by 7 and the last 3-digit number that is divisible by 7. That we have found. And also we know that if it is divisible by 7, it will be a AP with a common difference 7. Every number if you see the difference will be 7. Thus, we have to find the number of terms in this AP where A is equal to 105, D is equal to 7 and last term is equal to 994. So we know that An is equal to A plus n minus 1D, correct? An here is 994, A is equal to 105 plus n minus 1 and D is nothing but 7, or n minus 1 is 994 minus 105 by 7, correct? So if you solve this, you get n minus 1 is equal to 129, or you get 127, or you get n is equal to 128. That is my answer. So there are 128 terms, 128 3-digit number which are divisible by 7. Let me repeat what we have done. The trick here is we have to first find the first 3-digit number which is divisible by 7 and then we have to find the last 3-digit number that is divisible by 7. We have got a series where we have A, we have D and this is An 994. We have to find the value of n and the n came out to be 128. So we can say that this is A1 actually, this is A2 and this is A128. Since this is A128, I can say that there are 128 such terms which are 3-digit and which are divisible by 7. Let's take one more example. How many multiples of 4 lies between 4 and 250? Between 10 and 250 actually. So if you start with 10, 11, 12, 13, the first number that is multiple of 4 is 12. So we'll start the series with 12. The next number will be 12 plus 4, 16 and 20. Because if you keep on adding 4, those numbers will be multiple of 4. Correct? Because if 12 is a multiple of 4, 16 will also be a multiple of 4. Correct? Because 12 is nothing but 3 into k. 16 is nothing but 3 into k plus 1. Sorry, 4 into k. 4 into k plus 1. Because you are adding 4, 4, 4. So it will be 24 dot dot dot. And now we have to find the last number that is multiple of 4. If you divide 250 by 4, what you get is 4, 6, 24, this is 10, 2, 8, you get 2 as remainder. So that means 250 minus 2, that is 248 is divisible by 4. The last number here will be 248. Why? Because our range was 10 to 250. In 10 to 250, we know that 12, 14, 16, 24, 248 are divisible by 4. This is the range we have got. From that range, we have found the range which we are interested of. That is the number which are multiples of 4. And we got those numbers as 12, 14, 12, 16, 20, 24 till 248. So here also we know that A is equal to 12, D is equal to 4. This we know. If we subtract this to 16 minus 12, 20 minus 16 you get. Now we have to find the value of n. Same formula. An is equal to A plus n minus 1D. Correct? An is equal to 248. Is equal to A is 12 plus n minus 1 into 4, or we get n minus 1 is nothing but 248 minus 12 by 4, that is 236 by 4, that is 459, or we get n is equal to 60. That is my answer. So there are 60 multiples of 4 between 10 and 250. See, in most of the question what we have to do, you will be given a bigger sequence, a bigger series, right? This one. From this you have to find the series which you are interested in. So here our numbers are 12, 16, 14, 24 till 248. Now we know that this is A and the D is 4 and this is the last term An. right? And an come out to be 60, so this is a60. Since this is a60 and this is a1, we can say that they are 60 terms. The question says we have to find the value of n for which nth term of two APs are equal. There are two APs actually, AP1 63, 65, 67 dot and AP2 that is 3, 10, 17 dot. So in this AP, A is equal to 63 and D is equal to 2. To find difference, 65 minus 63 2, 67 minus 65 2. In this AP, A is equal to 3 and D is equal to 7. Why? 10 minus 3 is 7, 17 minus 10 is 7. The question says there is some an term in both the AP which are equal. So if you see an term of first AP is nothing but a plus n minus 1d, that is 633 plus n minus 1 into 2. For second AP, the an is nothing but a is 3 plus n minus 1 into 7. The question says that both are equal. So I can equate these two, I get 63 plus n minus 1 into 2 is equal to 3 into n minus 1 into 3 plus n minus 1 into 7. Or I'll take this 3 this side, I'll get 60 is equal to n minus 1 into 7 minus 2. That is n minus 1 into 5, correct? 5 will cancel with this, I'll get 12. I'll get n minus 1 is equal to 12, or I'll get n is equal to 30. That is my answer. Very simple. We have two APs. I wrote the general term of both the APs. An is equal to 63 plus n minus 1 into 2, and an is equal to 3 plus n minus 1 into 7. Both are equal, so I equated this and I solved this to get n is equal to 30. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.